All right. Um, okay. Um, Now we're gonna be doing this cosecant um, uh, pi x. So basically, amplitude start off the bat is 1. Frequency is pi. Okay, yeah, I got confused for a second. Um, Period is 2 pi over b, which is 2 pi over pi, which is just 2. 2 over 4 is 1 over 2. Phase shift, none. Vertical shift, none. So now cosecant is a little weird. So let's start by writing down our amplitude right over here. So amplitude is 1, negative 1. And remember, cosecant is the opposite of sine. So, yes. Now, the way we'll write this is here, 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 and here. So, cosecant, you can also put this into your calculator to remind you. Forget, I'll send away if you guys want. I just have to remember it. So basically, the way it works is you write it like this, and it'll follow down to here, where this will go. You'll have a dotted line, and this dotted line will go to here, which is where another thing would go. But that's how you draw it, and then and then I guess you have like a little, if you want, little thing showing the normal sign, and now let's write the periods. So the first period is 1 over 2, and then this is 1, because 1 over 2 plus 1 over 2 is 2 over 2, and that's 1. And then there's 3 over 2, and then 4 over 2, which simplifies down to 2. That's how you do the cosecant. And again, calculator is going to be your best friend for this, because yeah, like it'll have it'll remind you about what each thing shows. Now secant 3x, so our amplitude is going to be 1 because there's no coefficient next to secant. Frequency is 3. Period is 2 pi over 3. Period over 4 is 2 pi over 3 times over 1. That's cross multiply, so that's 2 pi over 12 pi over 6. Pi over 6. Great. Now our phase shift is none, and vertical shift is also none. Wait, did I do that right? Yes, I did. Awesome. Now let's zoom into the graph, because I realize it's a little hard to like see without that. And so yeah, now I have secant is like cosine. It's the opposite of cosine, 3x. So the way that it'll work is, because we have our amplitude at 1, we'll actually put it up here, 1, and down here, -1. And the way that it'll work is go up here, and here, and here. I'm doing it every 2 just so it's spaced out nicely. She also does that, in case you were wondering, because it just makes it a whole lot more clearer. And now we're gonna draw the secant thing. It's like this. It's very similar to the cosecant in the way that it's like that. And basically, you might notice that I skipped over some of these ones, because like this one and this one, because you're not supposed to do that. That's just it, like sort of, it's like the asymptote between the each of these cosecants. The asymptote, again, is also where it just barely is about to touch the line, but it doesn't. All right, now tangent x. Okay, amplitude is 1. Frequency, also 1. Period is pi over b, which is just pi, because it's when, I guess when looking at this, like when for like tan, it's a period is just pi over b. So pi over 4, period over 4 is pi over 4. Phase shift, none, none. Okay. Now, have this right here. And we're going to go like this and like this. Have the 1, negative 1, and the 1. Okay. Now, let's fill this in. The way that a tan is like this. Where it's like that, yeah. And basically, and then cotangent is the opposite. It's like this. I guess a way you can look at it is like the way that you would usually order something is the normal version and then the opposite. Like you'd first say, this is I don't know. But anyway, like think of it like this. This is a way to remember it. Here, this is a person. This is how, oh, that looks like a headless guy. How would it go? Because tan is like normal, and like the tangent is like the more simpler kind. Like think of it as like a business strategy. Tangent is good, while cotangent, your coworker, cotangent is bad. So the graph will be going up because business is booming. It'll be going down for cotangent. I don't know. Anyway, so yeah, so tangent is going up, and we can sort of find the x values over here. Period over 4, pi over 4, but it's negative pi over 4, and then positive pi over 4. And you'll also have to sort of draw the little line over here to show that it doesn't quite, like it's about to touch it, but it doesn't quite. And then you have to write which thing it is. So it's pi over 4, 2 pi over 4, which is pi over 2, and negative pi over 2. Okay, now cotangent. Cotangent is going downwards, so it's like this. Amplitude is 1, frequency is 1, because yeah, there's nothing there. Period is pi, because it's pi over b, and b is 1, so it's just pi. Pi over 4 is here. Phase shift none, vertical shift none. Okay. There we can. Okay, so the way that this one will also work is that we're not gonna start it by the beginning, because the beginning is where it's gonna just barely touch, because this is also still a thing. Also, you can still keep doing this with the calculator. I'll get to that either in another video or afterwards. Pi over 4, 2 pi over 4 is pi over 2, and then 3 pi over 4 is 3 pi over 4, and then you have these. These little guys where it'll just barely touch, so we're gonna draw that line, and this is at, of course, the 0 part, and this is the 4 pi over 4, which is just pi. Awesome. Now, graph sine inverse of x, make an xy chart. So first let's start with y equals sine x. And so the way we're going to do that is, again, you can also use your calculator. So we have a chart here, x and y, x, y. We're going to start with the y part over here. And so it's negative pi over 2, 0, pi over 2. Because, yeah. And then for y equals sine inverse of x, it is negative 1, 0, 1, and it's just the opposite of that. Okay. There, pi over 2, negative pi over 2, because it's basically just flipping over. Great. And now graph y equals cosine inverse of x. Make an xy chart. So yeah, and then, okay. Basically for the sine inverse, sine inverse looks like this, going up, right? Yeah, like if we do go to the y equals sine inverse of x. Okay, graph that. Oh, it doesn't work so well. Oh, right, okay. Yeah, because the calculator doesn't like it. But basically that's how you would do it. And then always know. Okay. Always know which one. Always know that cosine, like that in a full thing, you're gonna have pi. It goes up to pi, right? So like, how can I word this? I asked here. So let's go to another question, and we'll go back to here. So I also want a tan inverse, by the way, is like this, but we're also gonna go back to that later. Or if I forget to and just publish a video, please text me if you want it. All right, so let's go to here. Okay, yes, here. Okay. Okay, which is an equation of the graph shown below. So if it were cosine half x, that means that it would go. So let's start with what's a cosine full x, like just cosine x. Cosine x would go like like it would have a full thing. It would have full thing by 2 pi, right? Because they're all, if it goes up to 2 pi and like a full thing, then that's cosine x. If it did it twice before 2 pi, so let's say like this, then it'd be cosine 2x. Cosine half x would be exactly like this, because it would take double the time. And then sine is like the same thing, except sine would start here. Sine x would be like that. Sine 2x would be full 2 things before the 2 pi. And sine half x would be like this, because it would go on to double. Okay, so this is cosine half of x. Which equation is represented by the graph below? This is since the amplitude is half of x, we already know that's half x. So we can cross out the 2. And it's sine because it's starting here and it's like this. So we can cross out the cosine. And sine, it has to be possible. And it's full because you see how it goes down by the 2x? That means it's full. Because it did a full thing, like if it was sine here. Oh, right. Okay. Alright, I have to go now, but I'll continue the video later.